Let us look at the gradient, how you find the gradient of a straight line. This is our straight line right now. Now we want to choose 2 points on the line. Let's say we have this point. We have our x and y that we're going to put there, and we have this point. We're going to have our x and our y. Let's say this is point 1, so we have x1, y1. This is point 2, so we have x2 and y2. Now we know that the gradient of the line can be found if you draw a right angle triangle. That means from one point you draw a vertical line, from the other point you draw a horizontal line, then the height of the triangle is the rise and the width of the triangle is the run, and you calculate by placing rise over run. So if we have our triangle here, let me get this x and y out of the way. We have our triangle here. This point is x1, y1. The coordinates of this point are x1, y1. Coordinates of this point are x2, y2. So let me rewrite this. We have x2, y2. Now we will see that this height up here is our y2, and this down here is our y1. We're going to calculate our rise and then divide it by our run. How much this triangle rises is our rise. So the difference between y2 and y1 is our rise. So we say up here, y2 minus down here represents our y1. So we say y2 minus y1 divided by, now this point and this point here we're going to concentrate on with respect to how or which x value it is above. Alright, which x value it lines up with vertically. Now this x2 would be this here. This is really our x2, and this x1 is really above this value here. This is x1. So the width of the triangle is x2 minus x1. So we have our formula here. y2 minus y1 over x2 minus x1. Where, as we can see, this y2, this is y2, and this is y1. The rise is the height of this triangle, y2 minus y1, over the run is the width of this triangle, where we see that x1 is above right here. We just relabel it, and y and x2, this point is above right here, so we label it x2. All right, now we could switch them around. You could try that on a sheet of paper. Switch them around. Call this x1 y1 and this x2 y2, and we will see that we would get y1 minus y2 over x1 minus x2. So this is a formula that you could use to calculate the gradient. Or of course you could just do it by drawing the triangle and see the height, which is the rise, over the width, which is the run. Now let's look at the numbers here. The numbers that we're talking about. Let me put my x1, y1 further out. This point will be right here, will be our x1, y1. So x1, y1. And this point is our x2, y2. Now, on this particular graph, we see that this point is above 6 on the x-axis and beside 9 on the y-axis. So the point is 6, 9. 6, 9. The coordinates of the point are 6, 9. This point is above 2. So x1 is 2, comma. It is beside 3 on the y-axis. So y1 is 3. Alright? Because we have our x-axis, horizontal axis as always, and our y-axis, vertical axis as always. Now, we can see that by drawing, if we should draw our right angled triangle by drawing a vertical line from one point and a horizontal line from the other point and see where they intersect, and we draw a triangle, the height of this triangle is from here 1, 2, 3, 4, 5, 6 units. So our rise is 6 over our run. What is our run? 1, 2, 3, 4. So between this point, height 1, 2, 3, 4, 5, 6 high, while our run is from here 1, 2, 3, 4 over 4. So 6 divided by 4, 2 into 6, 3, 2 into 4, 2, 3 divided by 2, which is 1.5, 1.5. So our rise over run gives us 1.5. That's our gradient, right? Let us erase this triangle and our markings and use the calculation and see if we get the same thing. Our rise over run, in this case, y2 minus y1 over x2 minus x1 equals, our y2 is 9. 9 minus our y1 down here is 3. 3 divided by x2, our x2 is 6, minus our x1 is 2. So we have 9 minus 3, which is 6 divided by 6 minus 2 is 4. 6 over 4 is 1.5, just as up here. Alright, so we got our gradient by both drawing and calculation. Okay, good. So that's the gradient of our line here. I'll see you in the next video.